All right, so what I'm going to do now is go over how to use the box and X method for factoring quadratics. I know these are quadratics because of x squared. So first thing you do is you need to set up an X or a diamond problem where you put the first term times the last term at the top. So x squared times 21. We don't always use the variables when we're doing this. Sometimes we just use the coefficients, but I want to kind of show a little more thoroughly how this works and everything with the variables. So we get 21x squared up top, and then the middle term goes on the bottom, 10x. So the point of this is we need to figure out two numbers that multiply to the top and then add to the bottom. For this purpose, we're just really going to think about the numbers 21 and 10. So we need two numbers that multiply to 21 and add to 10. So for 21, there's not very many ways to get that. 1 times 21. Obviously, 1 plus 21 doesn't give us 10, but the other way, 3 times 7, that gives us 21, and it does actually give us 10 when we add them, 3 plus 7. So the answers to this diamond problem, the solutions here are 3x and 7x. And the whole point of this is to be able to split our original trinomial into 4 terms. So we would end up with x squared plus, now this 10x is what's being split. It's being split as 3x plus 7x. That's an equivalent way to write 10x, and still plus 21. These 4 terms are what we would get when we multiply the 2 binomials that this actually factors into. So now once I have this, I can fill out the box. And the box is how we're going to get our 2 binomial factors. So x squared, 3x, 7x, 21. Some of you might be kind of yelling at the screen right now because we probably can take a much faster way to factor this particular problem, but I'm showing the whole process here. So we look for what does each row and each column have in common? What are the common factors? So in this top row, they each have an x, but between these two, they don't have any common numerical factors. 1 and 3, the only common factor there is 3. Here in this row, 7x and 21, they don't both have x's, but 7 and 21 both have 7 as a common factor. So this is going to be one of our binomials, x plus 7. They can even write that out. And then right here, we're going to look at the rows. So this column, rather. This column has an x in common, and then 1 and 7, they would only have a common factor of 1. 3 and 21, they both have a common factor of 3. So that's going to be our second binomial factor, x plus 3. And notice that if I were to try to multiply these back out, I would get exactly what's in the box. And I can kind of show that, again, by sort of checking it. But if factoring is our only goal, this is our answer. These are the 2 binomial factors. But if I want to go ahead and multiply this out, x times x is x squared, x times 3, 7 times x, 7 times 3, combine the like terms, and there you go. It's the same as our original problem. So this is the correct answer right here. This is the correct factoring of that original. Now this one was an easy one. There are ways to just do the diamond problem or the X problem and see, okay, 3 and 7, okay, those are going to be our 2 answers. But I'm showing the whole process. And when we start off with a harder problem, we're going to have to kind of go through the full steps. All right, let's go ahead and do the next example here. And this one's going to be just a little bit more complicated. The main reason I know it's more complicated is this first term, 3x squared. Anytime we have a number there in front of x squared, that is going to make it a lot more challenging. Depending on what it is, it could be very challenging. All right, so setting up our x problem, we have 3x squared times negative 16. That's going to give us negative 48x squared. And then our middle term, negative 8x. All right, there are a lot more factors for 48. Because remember, we're looking for two numbers that multiply to 48, negative 48, and add to negative 8. There are a lot more factors for 48, so I'm going to go ahead and go through those. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. So a lot more options here. Last time we only had 2. And to top it off, we know it's actually got to be negative 48. So one of these factors is going to be a negative number, and one will be a positive number, so that I'm multiplying at negative 48. Now, that really means that it could be 1 and negative 48, or negative 1 and 48, and kind of so on with all of these. But I can use this one to help me out. Since they add to a negative, I know the larger number has to be negative. So the 48 would have to be a negative, or the 24, or the 16, or the 12, or the 8. That just kind of cuts down on all the options I have to try. Now, I'm going to kind of eliminate them. When I add these together, definitely don't get negative 8. When I add these together, again, negative 22. Closer, but still not the right answer. 4 and negative 12. That is the one we're looking for. So we get 4x and negative 12x. But just to check things, yeah, that will give us negative 2. So that's the right one. That's how we're going to be splitting this middle term. All right, we're going to split it as positive 4x and minus 12x. And I might as well write the rest of this out since we are going into depth here. All right, so here is our expanded polynomial that we can use to fill into our box. And then we can factor. We can find out what numbers or factors each part has in common. I start with the rows and then I do the columns, but you can really do it in any order. So right here, we have an x. 3 and 4 would only have a common factor of 1, so I kind of ignore that. These are both negative, so I know there's going to be a negative here. And no x's in common, but they do have a common factor of 4. That's the greatest common factor there. Here, they both have x's, and 3 and 12 have a common factor of 3. And you can also kind of quickly check, do these multiply outright? Yep. Do these multiply outright? Yep. All right. And then the last one, column here, they have a common factor of 4. They don't both have x's. They're not both negative. So, yeah. And when I multiply all this out, yep, checks out. So these are going to be our answers. X minus 4, 3x plus 4. This is the factored form of that polynomial. Factored form is very useful for simplifying, for solving, for all kinds of things. So we need to be able to factor accurately. And you can sort of see just by using the box method, we're pretty sure that it does work.